This is going to be a series of reviews for the Chapter 5 material that we're currently going over. And I'm going to keep it straight to the point. I'm not going to go into the definitions from the previous course. Just more skills approach on these radicals. So let's go ahead and get started. So I've got to simplify my radicals. And for the method I'm going to show you, you need to pretty much have your perfect squares memorized. Your perfect squares stem from things like 2 squared, 3 squared, 4 squared, so on. So you got 4, 9, 16, 25, 36, 49, and so on, okay? So what we got to do is take a look at this number and find the biggest perfect square that goes into 48. Well, you can start at the big numbers and work your way down. 49, 36 obviously don't do it, neither does 25. 16 does. 16 goes into it 3 times. So all we're going to do is just rewrite this radical as 16 times 3. Take the square root of 16. That comes out, and square root of 16 is nothing but 4. So that's just 4 radical 3. All right, so that's my answer for this one. So let's take a look at this, 72. So 72, biggest one, we start here. Nope. 36? Absolutely. And this is nothing more than 36 times 2. And if you remember your rules of exponents from Algebra 1, this is nothing more than 36 times radical 2. We could take the square root of 36 right here. That's just going to be 6 radical 2. Again, this method depends upon you knowing your perfect squares. Last one, 75. And, we can have 64 down here and so on. We just work our way from the big numbers and work our way down. And guess what? 25 goes into it 3 times. And we have 25 times 3. And if I wanted to write these as 2 separate radicals, I can from our rules of exponents. Okay, there we go. So we have radical 25 times radical 3. And of course, this is nothing more than 5 radical 3. So that's how you're going to approach all these. And again, we're keeping these very, very basic. We're not throwing in variables, x squared, things like that. Now, in my course and all the other teachers' courses, we rationalize the denominator. That's basically we're going to get rid of the radical, the square root, in the denominator. And by doing that, we're just going to multiply by 1. And our 1's come in the shape of whatever this radical is, itself over itself. So radical 7. And we multiply straight across. Remember, when we multiply, radicals play with radicals, numbers play with numbers. So that's just 5 radical 7. And radical 7 times radical 7 is radical 49. Square root of 49 is just 7. So in essence, this just cancels out the radical. And again, back to the definitions, 1/2 power, 1/2 power. Rule of exponents. That's what happens there. You may want to go back and review your rule of exponents. Okay, so exactly, we take a look at this and see, oh, this is radical 2. Multiply by radical 2 over radical 2, which is nothing more than a fancy 1. Multiply straight across. And we have 2. Now this right here, number plays with number. So these guys right here, 6 over 2, is nothing more than 3 radical 2. All right? Now, multiplying radicals. Basically, the rule is numbers play with numbers, radicals play with radicals. So let's take a look at this. Numbers play with numbers. 2 times 3 is 6. And radical plays with radical. That's just radical 18. We're not done. What's the biggest perfect square? Remember, 4, 9, 16, 25. Looks like it's going to be 9, this guy right here. So this is nothing more than 6 times 9 times 2. Take the square root of 9. Again, I could rewrite this as 6 times square root of 9 times square root of 2. That's just another way of writing the number 3. What's 6 times 3? 18. 18 radical 2. Got it? I hope so. All right, so one last example on this realm. So number plays with number, so that's a 12. And 10 times 5 is 50. Let's break this up. So that's just 12 times, there's 25 goes into it, 25 times 2. And I'll go ahead and break this up again just for the visual folks. 12 times radical 25 times radical 2. Just breaking up our rules of how things work. Square root of 25 is just another way to write 5. So that's just 12 times 5. So that's going to be 60 radical 2. One last thing. Adding, subtracting radicals. Now all we're going to do is take all our rules of exponents and carry it through. Now a technique that I showed you in class is we're going to basically take one at a time. I take this guy right here. And this is nothing more than 9 times 2. Plus 2, that's nothing more than 4 times 2. All perfect squares. And there's not a thing we can do with this radical 2. It's already simplified. So I go in here and take all my perfect squares, 9 and 4, and take the square root of them. That becomes 3 radical 2. That's 2. Now this 2 comes out and multiplies to that 2. So that is 4 radical 2 plus 5 radical 2. I count my terms. So I have 3, 7, and then 12. All right, so I have 12 radical 2. This is just showing your work and your steps. All right, just in case we do let you have a calculator, but I doubt it. One last example, and then we're done for this almost 8-minute video. Well, it might be 8 minutes by the time I'm done. So I just bring everything down. 2 radical 3, nothing happens to that. This is going to be, what? Yeah, 25 times 3. And I usually put my perfect square first and my other number last. 4 radical 2. And this guy right here is nothing more than 36 times 2. Plus radical 36 times 2. And why is it doing that? Oh, that's just downright ridiculous. Hey, my pen's acting up. Why? Why me? Why not that? Oh well. Okay, this is not cool. Did my thing finally break on me? Let's try a different color. I'm turning this into a very long video. Look at that. It's pretty. Okay, now I'm at a loss. My thing could be breaking. I'm going to end this video. All right? So you're just going to have to solve this one. But anyway, that's 36 times 2, so that's going to be 6 radical 2. And you just add up your radical 3s and your radical 2s, and you're done. So I'm going to upload this and then investigate why it's not working.